All right. All right, guys. Get back to it. So, 4142, we got these guys. All right. So remarkably enough, we're going to do 4-3 now. 4-3 goes back to an idea from before. When I gave you a problem, like, let's say I got, so 11% of Americans are left-handed. I was going to write American. Right? So if I had 5 Americans, what's the probability that the first one is left-handed while the last 4 aren't? Americans. Probability, first one's left-handed while the last, and this is really, I've been showing you this symbol. The book uses a stupid little prime. I use a bar over it to mean not left-handed. I don't want to put R for right-handed because that's not what not left-handed means. Right? You could not have any hands, and then you are not left-handed. So I want to include everybody. So do you see how this is a mathish way of saying this? What I said earlier, the first was left-handed while the last 4 aren't. Is that cool? So we know how to do this. This is not section 4.3. This is chapter 3. How do I set this up? But then I'm going to see the transition in in section 4.3. How would I set this up? Yeah, so I want the first one to be left-handed. That's an 11% chance. And then I got 1, 2, 3, 4 other people. And they're all going to have a what chance of being not left-handed? 89% chance. Does everybody see where that came from? Okay. So we've done a problem like this before, right? And then you just multiply all that business out. What is that? 9, 8, 7, 63, 06. I would say 059.
69.
Damn. Oh well. That's pretty close, right? It's not too bad. Well, I'm going to beat myself up a little bit. That's all right. All right. That's amazing. So, but do you see how precise I am? Do you see the difference between this question and this is now section 4.3, this question? What's probably that exactly one of them is left-handed, becoming left. That's a different question than this. This is really specific. The first one is left-handed. That is exactly one of them is left-handed. How many ways is there for one of them to be left-handed? How many ways? 5 ways. Right? This way, right here. I've already got one right here. Right. The first one is, and the last 4 aren't. Or, oh shit, what's happening? We all right? Come at me.
There are 16 ways it can be left-handed.
Say it?
There are 16 ways there can only be one person left-handed.
Nope. There's only 5 people. So if I want exactly one of them to be left-handed, it's either this guy or this guy or this guy or this guy or this guy. Or girl. I don't know what they are.
So it'll be 5.
Now watch. Keep going. Do you see what I'm saying? So that is one of the, this is one of the ways to do what this question wants. Is there another way to do what that question wants? Right, I can do it that way, or, and what does or mean? Add. Or it could be the second guy that's left-handed. You guys see that? Or the third guy that's left-handed. Or oh shit, I'm like crap. All right. Does that, let me just stop there for a second. Does that make sense? Five people, and I know that one of them, so there's 5 people right here, and one of them killed somebody. How many people could it have been? How many ways is there for one of them to have killed somebody? 5 ways. It could be you, or you, or you, or you, or you. That's exactly what I'm saying. Right? So this is a little less, nobody died up here. All right. Wow, you guys. Okay, now watch. This is kind of nifty. And of course, what's in between each one of these? We know already. What do we do here? Multiplication, right? So algebra doesn't like this shit. How do you say L times L complement L complement? How do you say that? It would be L times L this to the 4th, right? And aren't they all that? And how many are there? 5. So when I add this up, I'm going to get 5 of these. Oh, Jesus. It's freaky looking. So what's that probability? I know exactly what. 5 times, what's the probability of L? 0.11. And what's the probability of not L? So you can figure out what that is. Right? Now, so whatever the hell it is, somebody do that and tell me what it is. We quickly are going to leave this creating the list thing behind. We're going to quickly leave it behind. So let me ask you this. Anybody do that for me?
0.345. Oh wait.
3, 4, 5, 1?
Yeah.
Is that right? Okay. So you do another question here. See what I meant by chapter 3? The 2 really most important things are and is multiply, or is add. So if you find yourself saying and with multiple probabilities, okay. Saying or, add. So let's do this. Let's do a couple things. This is kind of clunky, ain't it? L with that, I was kind of like getting all freaky at the end, starting to write Arabic maybe a little bit. Right? Or not, anyways, Arabic. No, I wasn't really, but it was getting a little funky at the end. So let's say that the letter P is going to be what I call the probability of success, which in this case is probably being left-handed. Is that cool? So I'm going to use the letter P for a left-handed person. So remarkably enough, you can only use the letter Q for the probability of failure. And that's probably of not left-handed. Okay, so it's just a little bit more consistent then. I can always use P and Q. So these situations, these kind of problems are called binomial probability problems. Binomial. 2 possibilities, 2 outcomes. Left-handed or not. If I roll a die, is that binomial? No. It could be. I'm looking for a 5, so I can get a 5 or not a 5. There you go, it's binomial. So almost any situation can be binomial, right? There's 2 groups of people in the world, those who think you can make them into 2 groups and those who think you can't. All right. So for example, let's do something a little bit freakier. If I had 80 Americans, and I want to know the probability that exactly 11 of them are left-handed, why does that so desperately suck if I try to do it the same way we just did? Give me one way this could happen. The first 11 are successes, right? And then the last 69 are failures. Right? That's the first entry in the list. Or maybe the first 10, and then a Q, and then the other P, and then the rest are Qs. Or maybe the first 4, and the last 6 are Ps, and the middles are Qs. Or maybe, holy fudge. But, so what's consistent among every way to write it? How many Ps will there have to be? 11, and how many Qs will there have to be? There's got to be 69 because I got 80 freaking people. If there's 11 successes, That must be the rest failures. So the only part of the equation that I don't know, that I did know over there, is this number. What did this number mean? Yeah, 5 possibilities. That's how long my list is. Right? Can anyone give a guess as to how long the list would be if you have 80 people and you want to have 11 of them do something? Yeah. The list size is too damn high. Yes.
1.0.
Oh, there you go.
1.03 times 10
So-
to 13.
Yeah. So it's like a 1 basically followed by 13 zeros. That is how long that list will be. Have you guys ever heard the idea of how many possible combinations of toppings on a pizza? And it's actually in the millions, which will really freak you out. And it's just because of the number of toppings you could choose from. And then you add in maybe half of it is something, and maybe the other half is this, and maybe it's extra this or whatever. You get in the millions of possible pizza combinations. And now I want some freaking pizza. Shit. So, that is going to be the one part of this that I will let you just have the calculator do. Calculator is a very expensive counting machine, basically. So here's a problem where we need to count something. It'll do it just as fast as Yanni did. So let me show you how to get that part. So I really want you guys to see what's happening. Everybody is cool with this part of it? If I want 11 successes, that must mean 69 failures. So all I'm missing is this number. So it's going to be this number times 0.11 to the 11th times 0.89 to the 69th. I want 11 successes. The rest are failures. I just need to know how long the list is. Okay, so let's see how that calculator can do that for us. Come back. Oh shit, everybody got that? Before I cover it, turn this guy on. What do you got? Oh, okay. All right. So,
This is where we get the phrase, mind your P's and Q's.
I was gonna wait. I was seeing if anybody. No,
No?
it's not. Yeah, they think it's got to do with pints and quarts or something. There's a few, but it's not this. If anything, we probably stole from that. Right?
We're good at that.
Math people. Yeah, actually, you know, Americans, math people, we all steal all kinds of shit. All right. You got a word we like? We'll take it. And we'll screw it up like Chris Sandwich. So here's how you get that number. So let me say it like this. How many total people I got? I got 80. And I want to choose 11 of them to be left-handed, right? So when I make a list, I chose the first 11, for example. But I want to have every way from 80 people to choose 11 of them to be left-handed. Are you guys with me? Does that make sense to say it like that? Hopefully it does, because that's exactly what it's going to look like. So here's where this is. It's actually called combinations. This is a section that I wish we had time to do in probability. It's counting theory, which gets really interesting. It's combinations and permutations and blah, blah, blah. But the only one we got to worry about is what's called combinations. And actually, I'm going to call it choose. It's the letter C, which is beautiful. So here's how to get the calculator to tell me the number that Gianni gave us. 80, so put in there 80. Now go to math. And this is a probability idea. 80, you don't want National Public Radio, go to NCR. 80, choose. Big ass C is choose. Anybody know what 4 is, by the way? This isn't 4! This is, anybody know what that is? I know a few of you guys know. Exclamation mark, it's called a factorial. So like 4 factorial would be 4 times 3 times 2 times 1. 70 factorial would be 70 times 69 to 68 times 67 all the way down to 1. It's kind of neat. Anyway, So that's what that symbol means. There's all kinds of punctuation in this calculator. Do the third one, the choose. 80, choose 11. So yours might look a little different if you have an older operating system on there. 80, choose 11, enter. This is a really good time to make sure you guys know how to read this. Everybody get that? So this doesn't mean 1.05. This means 1 point this times 10 to the 13th power. So it's move the decimal 13 times, and that's the size of the list. Oh, shit, yeah. That's pretty big. 80 people, choose 11 of them. How many ways is there to do that? This, right? That many ways. That's freaking huge. Now tell me this. I'm going to put that number here. 0.11 to the 11th is going to be really, really tiny. And the 0.89 to the 69th is going to be really, really tiny. So if you put the whole thing in your calculator at once, it all averages it out to a normal number. Big ass, small ass, comes out to normal ass. Let's see if that's true. So if I put in there, just to put the whole thing in there at once, 80, math, probability, choose, 11. Now I got to hit the over arrow. Do you see how I'm down here? Now if you have an older calculator, it's got 80 NCR 11, just keep going. I've got to hit the over arrow. Times 0.11 to the 11th, right? So now we know what goes here is that times 0.11 to the 11th. I want 11 successes. And then I have to hit the over arrow to come out of there. Over arrow right there. You guys with me? I'll start over again. So let's see. No, Jeff. There we go. 80. Choose 11. Now I have to hit the over arrow to come back up to normal. Times 0.11 to the 11th. Now I'm up. I've got to get the over arrow, come back down. Times 0.89 to the 69. Let's see what you guys get. So do 80. You're going to basically do that one 80. And then math. Probability. Choose. Number 3. Choose 11. Now hit the over arrow so you come back up because you're right down. See it? Oh, hit the over arrow. Bam! Now you're on there. Times 0.11 to the 11th times 0.89 to the 69th.
Okay.
And make sure you hit the over arrow so you come back down. Math. Yeah, right there.
Yeah. Okay.
Yeah.
So
This
it's
is
whatever you want.
number choose amount.
But you can also change it to.
Okay.
Oh, go back. Put 11. You want 11. I hit the over arrow, come back down. Times 0.89 to the 69. What's that mean? No, what's it mean? No, read it. What's it mean? What numbers are it? Almost 10% chance of what? Get 11 left-handed people out of a randomly chosen 80. Yeah. This is the real bare bones of this idea, but you see how I could use this to see how many desks I might want, how many left-handed desks I might want in a room. Now, of course, in this room, the desks are uni-handle? I don't know. They work for both hands, right? But in another one where you got those funky little chairs that you can't even get into, you got to get enough left-handed ones. All right. Here. So now watch. Let's do another one real quick, just to show you the idea is very straightforward. Let's say that the probability somebody likes. Why do I always shit on Brussels sprouts? Oh, well, too bad. Brussels sprouts. Probably somebody likes Brussels sprouts. Let's say it's 17%. Right? And I pick 29 people at random. What's the probability that exactly, what you got, Jeff? I don't know. Let's say 5 of them like BS, like Brussels sprouts. All right, so let's see. Can we summarize the important things that we know? What's little p gonna be? What's the success up here? What are they looking for? Yeah, people that like Brussels sprouts. So success in these problems don't have to be happy things. The success could be finding a dead body, it could be finding a rabbit, squirrel. It's just whatever I'm looking for is a success, which kind of makes sense. So the probability of success is 17% because I'm looking for people that like Brussels sprouts. So what's the probability of failure? 83. What's n? 29. And the number of successes I want, how few successes could I have? At any given moment, how few successes could I have? 1. 0. I like the optimism over there. But you could have no success. Up to what? What's the most successes I could have in this problem here? All of them, 29, right? Doesn't it have multiple values it could take on? Isn't that the variable then? So the number of successes that I want is 5. So those are the 4 main things to identify from a binomial situation. So how's this formula get set up? How many people do I got total? 29. How many do I want to choose to be successes? 5. And then I have, how many successes do I have? 5. I like that it's a little repetitive, right? 29 people, choose 5 of them to be a success. So how many of these do I want? 5. How many of the other one do I want? You could do it. Just 23, but how many do I want of those? 24, because I got 29 total people. You see that? What are the 2 exponents always have to add up to be? The total. Because I'm breaking them into 2 groups. Successes or failures. So take a minute, see if you can put that in the calculator, and then I'm going to write the general formula for this situation, and then I'm going to give you another handout. What the hell? The trees. Yes?
I think it's on the back of the handout you gave us.
Oh yeah, that's the one with the pyramid. There's a little more basic one we're going to start with, yeah. Let's see if I can use it. So just like that, right? Do you guys see? Can you see? Oh shit. Did I do stuff up there? I did. See over there, everybody? I'll look over there. All right. And then if you hit enter, let's see what we get. Yeah, a little under 20, like 19%, almost a little over 19% chance that out of any 29 people, 5 of them will like Brussels sprouts. It's about a 29% chance. How many would you expect to like Brussels sprouts out of 29? What percentage of people like Brussels sprouts in this problem? 17%. And I got how many people? How many would you expect to like Brussels sprouts then? How'd you get that? Yeah, how many people like Brussels sprouts? Out of any group of people, 17%. I have a specific group of 29. How many would I expect to like Brussels sprouts? 17% of 29. Expected value. So that's the formula for the expected value is another name for the mean or average. So this is our best mean formula yet. The mean for a binomial situation is n times p. Oh, that kicks so much ass. That's the first mean that we haven't had to actually make tables and shit, right? Right? It's just N times P. I mean, you know, if Shaquille O'Neal shot 30% of his free throws, I want to be generous. He made 30% of his free throws, and he takes 20 free throws. How many would you expect him to make? 30% of 20, about 6, right? You guys semi with me? A little bit? Not really? All right. Huh?
So what's he done?
Well, especially not anymore. He could barely walk around. Well, sorry. Fortunately, he was a Celtic for a while, but doesn't undo his years as a Laker. He was on the Magic before that, but oh well, too bad. So that's for any binomial situation. That is the formula for the mean. And of course, what else do I want to have a formula for? Standard deviation. Anytime I have a new way to be given data, I need to figure out possibly another way to figure out the mean and the standard deviation. This one I can't really fully. There's a little more to it than, anyway, that's what it is. Square root of n times p times q. There's a little bit more math that goes into that one. The mean makes total sense. Standard deviation is a little bit more to it. Okay, maybe. That's beautiful. So for xp of x, mean is sum of xp of x, and standard deviation is sum of the x squared p of x minus mean squared and square root. Oh shit. Binomial, bam. Kick ass. What about the formula for that probability? What was 29? It was n. N choose number of successes, x. 0.17 was p, so I want x successes. How many failures do I want? How did we get 24? N minus x, 29 minus 5. The total minus how many I used here. That's how many's left. Ermagerd. Let me give you this handout. This time there's not a worked out example in the back because I'm just tired of doing that for you. I'm tired. Don't do the side that's got more words. Do the side that's got, it says binomial probability practice on the top. It's kind of a giveaway.
So that one? Yeah, I think
Am I putting this in wrong somehow?
Yeah. Do a couple things for you. So right here, do you see? Oh, you put in like an exponent. So, all right. So hit 29. Now go to math. Yeah. Choose. So see, you have an older operating system. So you just, it doesn't show you like the subscript stuff, which is almost better. So 29 choose, what was it, 5 times. And just keep going. 0.17 to the 5th. Right?
So that's not on top, right? That's on the same level.
Same
So
level,
the
times
okay.
0.17.
Oh, so that's
to
probably
the-
to the.
Now you do have to keep, yeah, 5th. Yeah, good. And then times, yeah. So yeah, that was my fault. You're trying to make it look the same as mine. Mine's got a little newer system where it puts subscripts. Yours doesn't. So it's
Okay.
kind of nice. You're all at the same level to begin with. Yeah.
Okay. Okay. Got it. Thank you.
Sure. I was trying to.